Assalamualaikum and greetings to all of you. This is the presentation for the Invention project titled Enhanced Blood Vessel Extraction Program using MATLAB. As for the introduction, blood vessel extraction program had been developed and designed by various researchers using several image processing techniques because it refers to the retinal image with the blood vessel architecture. With the variety of techniques and methods, there is some highlighted issues had arisen, which are the simplicity of the transformation design, the accuracy and sensitivity which related to the overall performance analysis based on their results and the actual results. The aim and the motivation of this project is of course by enhancing the blood vessel extraction program with new mathematical morphology techniques which are simpler but can deliver high performance results. Entire proposed technique is programmed using MATLAB R2019A software. The background of the project is based on the patient who suffer from diabetic retinopathy. This visual impaired disease had caused difficulties to the patient, and if this is not treated, the patient might become permanent blind. For this project purposes, we are using the set of retinal image database which contains normal, non-critical and severe diabetic retinopathy condition. This database is retrieved from STARE, which stands for Structured Analysis of the Retina. This database complete with the retinal image and the blood vessel image which is illustrated by hand by an ophthalmologist. The figure shows an example of retinal image retrieved from the STARE database. And this is the final result of blood vessel extracted from the retinal image using our program. The figure shows the methodology flowchart of the project, which the identified area that will be enhanced. The mathematical morphology is the crucial part of the whole extraction program. This will determine how the retinal image could transform into blood vessel before proceed for further image construction along the way to the final output presentation. The process starts with the original retinal image loaded into the program. Then will be converted into a grayscale image by using green channel only. Next, it will be transformed with the application of top head and bottom head image transformation technique in the mathematical morphology section. The mask generation is important to generate the region of interest for image and background separation. Then, match filter is applied to the retinal image. This is where the cross-sectional approximation carried out on the blood vessel image by applying convolutional method at each pixel to gain maximum response. After that, local entropy thresholding is applied to the retinal image. This is where the gray level exploitation carried out on the retinal image, which corresponding to the maximum of total second-order entropy for optimal object background classification. And lastly, length filtering will remove isolated pixel for a smooth image of blood vessel. The figure shows the overall steps of the enhanced blood vessel extraction program, which indicate each of the steps as mentioned in the methodology. Because of this project used the database from STARE, we enable to get the performance indication of this project by comparing the results of the program and the actual result from the database. This will bring the attention to the true positive, false positive, true negative and false negative, which is directly related into a pixelation construction of both of the image. The indicator for the performance is the sensitivity and accuracy. The result of this project is the software of blood vessel extractor as shown in the figure. The highest accuracy achieved is 0.95 and the sensitivity is 0.85. As for the summary, with this project, we demonstrate a new mathematical morphology approach with the combination of top head and bottom head image transformation technique to improve the retinal blood vessel image conversion. The innovation is shown through the image processing design with the programming algorithm used a simple technique but yet had given a good performance results. This project is commercial ready product as it can be used straight away by the ophthalmologist and can be incorporated with the ophthalmoscope. With that, I end up my presentation. Thank you.